We are continuing with our Cyclic geometry series. In this lesson, we are going to summarize all the 10 theorems or other properties we have covered from the previous videos, and then we are going to solve 2 examples from past papers. Now let's go straight to it. The first theorem was the theorem on angle from the center. Angle at the center theorem. Let's talk about it. What does it say? It says that the angle at the center is twice the angle at the circumference. Angle at the center twice the angle at the circumference. Now, when you are reasoning with these theorems, you are always going to use this short form for them. Just use this. Even the long one, it's acceptable, but then to save yourself time, just write angle at the center equals to 2 times angle at the circumference for your reasoning whenever such a theorem is used. Number 2, angle in a semicircle theorem. The short form for its angle in a semicircle is equals to 90 degrees. So what does it say? It says that the angle subtended by a diameter at the circumference of a circle is 90 degrees. So once the angle is arising from the 2 ends of the diameter on the circumference, you are definitely going to have a 90 degrees. So that's the angle in a semicircle theorem. Next theorem, theorem number 3, angle in the same segment. This one is saying angle is subtended by the same chord at the circumference is of a circle on the same side of the chord are equal. Angle subtended by the same chord, sometimes we are saying is the same arc. It can be arc. If the chord has not been drawn there, you cannot say it's angle subtended by the same chord. You just say the angle is subtended by the same arc at the circumference of a circle. Once they are on the same segment or on the same side of the chord, these angles are going to be equal. Next theorem, opposite angles of a cyclic quadrilateral. Now, cyclic quadrilateral, just recall, all the 4 vertices of the quadrilateral are on the circumference. What does it say? It says that the opposite angles of a cyclic quadrilateral are supplementary. That is, they add up to 180 degrees. So its short form, its opposite angles of a cyclic quad add up to 180 degrees. So whenever you are reasoning, to save yourself, just use the short forms. Next, exterior angle of a cyclic quadrilateral. The exterior angle of a cyclic quadrilateral is equals to the interior opposite angle of the cyclic quadrilateral. And then its short form, it's just that's an obvious one. Exterior angle is equals to the interior opposite angle. We've just committed a foul. We've just talked about something obvious. In cyclic geometry, you will never ever use the reason it's obvious. Nothing is obvious until it's proved. So you must use the proper reasoning. Don't commit the foul of just committed by saying it's obvious. We don't do that. We don't do obvious things here. Provide the valid reasons, and then all these reasons from this theorem is just the short forms. Now, exterior angle of cyclic quadrilateral is equals to the interior opposite angle of the cyclic quadrilateral. Next theorem, radius tangent theorem. A tangent to a cycle is always perpendicular to the radius at the point of tangency, or rather at the point of contact. Once there is a radius from the center to the point of contact of the tangent, where the tangent touches the circle, once the radius meets a tangent, the angle formed is always 90 degrees. So this is the short form. Tangent is perpendicular. This symbol is for perpendicular to radius. Next, theorem number 7. Perpendicular from center to a chord. The line drawn from the center of a cyclic to the midpoint of a chord is always perpendicular to the chord. If you draw a line from the center to the midpoint of a chord, it's going to be perpendicular to the chord. And then the opposite is true. If you draw a line to the such that it's perpendicular to the chord, it's going to bisect that chord. So the short form for this one, center to midpoint of chord, is perpendicular to the chord. Just remember this is the symbol for perpendicular. Number 8, equal chords are equidistant from the center property. Now this one is self-explanatory. Now let's check the full statement. 2 or more equal chords in the same cycle are always equidistant from the center. If you can draw 2 chords or more in one cycle such that those chords are equal, they are going to be equidistant from the center. That means that the perpendicular bisectors of these chords from the center, they are just going to be equal. This is equal chords implies equal distance from center. That's the short form of this theorem. Number 9, tangents from the same external point property. Now 2 tangents drawn from the same external point to a cycle are equal in length. Tangents from the same point are equal. That's the short form for this one. Next, the alternate segment theorem. Now just a reminder, a segment is something like this. Let's say you have your cycle and then you draw a chord in the cycle. This thing has just divided the cycle into 2 parts. This is a segment and this one is a segment. So now the alternate segment theorem is just something to say one of the angles is on the other side of the, and then the other one is on the other side. But then for same segment theorem, both the angles are on the same side of the chord. Now let's read the full statement here. What does it say? The angle between a tangent and a chord. Angle between a tangent and a chord. Let's try to draw a tangent here. That's a tangent and this is a chord. So this is the angle between tangent and the chord. This one is equal to the angle subtended by the chord in the opposite arc. So this is it. So what does this thing say? It says that this angle is equals to this one. This is the angle between the tangent and the chord. So it's equals to the angle subtended by the chord. There you go. Just like that. Short form, angle between tangent and chord is equals to the angle in the alternate segment. Or you can just say it's angles on alternate segments are equal for this one. Now that we are done with recapping this theorem, so if you are willing to go into the details of this theorem, just feel free to go to our previous episode from episode 2 to episode number 10. You will get all of this explained in details. Now let's go to the examples. Our example number 1. There you go. Well, this is an extract from a paper 2 question from the NSC syllabus, National Senior Certificate from South Africa. Now let's check this question. In the diagram, O is the center, there is O of the cyclic. Now K, T, L are points on the cyclic. K, T, L, they are points on the circumference. K, T, T, L, K, L, OK, and OT are drawn. OT intersects KL at M. OT intersects KL at M. And then ST is a tangent. This is a tangent to the cyclic. This one is a tangent. Let's just label it as a tangent. And then STK is 36. This is what we have been shown. And the OKT, OKL, OKL is 8. So this one is supposed to be 18, not 36. OKL, OKL, this is 18 degrees as shown on the figure. This was a typing error. Now, let's check the questions. Calculate with reasons. No. Here's the field for cyclic geometry. You are required to supply reasons, proper reasons. Not just it's obvious. Once you write it's obvious, just know you've successfully awarded yourself 0 marks. Now we are required to find T2. T2 is this angle here. How do we find that angle? Now I'm seeing something here. This is the tangent. And this is a radius. Once a tangent meets a radius, the angle between them is going to be 90 degrees. Just like that. Let's just write that statement. STO. STO is equals to 90 degrees. Reason, tangent is perpendicular to radius. Next statement. Now, STO has got two angles. There is T1 and T2. So STO is equals to T1 plus T2. Now this is 90 degrees is equals to T1. It's 36 degrees plus T2. Now, what are we going to do here? We need to get rid of the 36. So we just need to subtract 36 from both sides of the equation. Subtracting 36 from both sides of the equation, we are getting rid of this one. And then you are left with 90 take down 36. It's supposed to be 54 degrees is equals to T2. We have successfully answered the first one. Second one, L, you are required to find the size of angle L. Now this is L here. Let's check. Let me remove this one. Remember, this is a tangent and this is a chord. And then this chord is subtending angle M, angle L rather. So your angle L is actually equals to 36. What's the reason for this one? This is a tangent. This is a chord. And then the angle between them should be equals to the angle in the alternate segment. And then the angle in is this one. So this is the angle subtended by chord KL, and then it's supposed to be 36. That's the tan chord theorem. So angle L is equals to 36 degrees. Reason for this one, I just say tan chord theorem. Alternatively, you can reason with the short form of the statement just to say this one is the angles in alternate segment are equal. The third one, you are required to calculate KOT. KOT. How do we find KOT? Where is KOT? It's that angle there. This one. This angle here. And then this is the angle at the center. And this is the angle at the circumference. So we've learned a theorem that says the angle at the center is twice the angle at the circumference. So maybe let me put this one here. We'll take it down to its working space. KOT is equals to 2 times angle L. Angle at the center twice the angle at the circumference. Angle at center is 2 times angle at circumference. Then from there was KOT. It's the one I'm looking for. This is equal to 2 multiplied by angle L, which is 36. So my KOT is equals to 72 degrees. We take it down. Yeah. Nice one. Our next example, it's an extract from the IGCSE mock examination 2025. Let's check this one. You are given a diagram as shown in the figure, and then you are having a 4-sided polygon whose vertices are on the circumference. Now, once you see something like 4V, so this is a cyclic quadrilateral. The theorem we've learned concerning cyclic quadrilateral is that its opposite angles add up to 180. This angle plus this one should give me 180 degrees. Angle A plus angle C should give me 180. Similarly, angle B plus angle D should give me 180 degrees. What's the reason for that? The reason for that is those are opposite angles of a cyclic quadrilateral. And then what else do I see? I'm seeing an angle at the center here, and then there is an angle on the circumference there, this angle here. So this angle is actually a half of this one, because the angle at the center is 2 times this one. So half of this one, that's 62 degrees. Just write it here. This is 62 degrees. Now let's go straight to the equations. Work out CBD. 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 CBD is equals to 62 degrees. Then what's the reason? Angle. Let's write the full theorem for this one, but the space is too much. Angle at the center is twice the angle on the circumference of a circle. Then you got your 2 marks. Next, work out angle BAD. BAD, where are you? BAD. Alright, to find angle BAD, we need to first know angle C. And then we already know a portion of angle C. Now check something here. Check this. This is a radius. Is equals to this one here, which is telling us that this angle and this one, they are actually equal. Let's call them something like X. Now let's work out this angle OCD. OCD is equals to ODC equals to X. What's the reason for this one? This one's a base angles of an isosceles triangle. Then to find the value of X, it's actually going to be X plus the angle at the center there, that's 124. This is giving me 180. And then from there, let's subtract. Before that, X plus X is 2X plus 124 is equals to 180. Then subtracting 124 from both sides, this 124 on the left, it's going to get cancelled out like that, and then you are left with 2x is equals to 56. Then dividing by 2 on both sides, x is equals to 28 degrees. So if this is 28, then the whole of angle C is 28 plus 35. So angle C is equals to 28 plus 35, and that's giving me 63 degrees. Now there's something I just wrote here. A plus C is equals to 180 degrees. Remember, we are looking for angle A, which is BAD. So our BAD is equals to 180 degrees minus angle C there, which is 63. And then this is going to give me 70. BAD is actually equals to 117 degrees. Now remember, for every statement we must put in a reason. Very important in cyclic geometry. Okay, this one, there is no reason for that. For this one, the reason is that these are opposite angles of a cyclic quadrilateral. So BAD is equals to 117. So the reasons are already there, but then we can put this one here. Opposite angles of a cyclic quadrilateral. Next, question number B. Calculate the circumference of the circle. So to find the circumference of a circle, we are going to use this formula. Circumference is equal to 2 times pi times r, or circumference is equals to pi times the d, which is the diameter. So between radius and diameter, what do we have in this circle? We have none of the two, but we can find the diameter as q if we can know an angle in triangle P as q. How can we find an angle? We can find the angle q down there. We can be able to find this angle here. Remember, there is a theory that says angles subtended by the same chord, angles arising from the same are equal. This is the same chord as P. So the angle up there, this one, is equals to this one, which means here I'm having 42. Let's just write it one down. So angle Q is equals to 42 degrees. Reason, very important. What's the reason for that? Angles on the same segment are equal, or you can say angles subtended by the angles subtended by the same chord in the same segment, just like that. That's the reason why Q is equals to 42. Now that this is 42, we have the angle we are looking for, the diameter there, so we are going to use the SOHCAHTOA there. Now we have an adjacent side and the hypotenuse, so we are going to use cosine. So this means that cosine of angle Q, or rather 42, is equals to the adjacent, it's 5.9, divided by the hypotenuse, it's what we are looking for, SQ. So this means that our SQ is equals to 5.9 divided by cos 42, just like that. Then this is our diameter, so the circumference is equals to pi times 5.9 over cos 42. So the circumference is going to be equals to 24.94183639679, and this is approximately 24.9. That's the circumference of the circle. Now thank you for staying tuned in this video. Stay tuned for more.